Formal charge is a concept used to select the best Lewis structure from several possibilities. The best Lewis structure is the one that minimizes all formal charges. To understand the value of formal charge, you have to temporarily forget what you already know about drawing Lewis structures. All the rules and tricks you've been taught came to exist as a result of the formal charge concept. While you watch this video, pretend you don't yet know how to draw a correct Lewis structure. Learn about formal charge, then you'll be able to look back at the rules and the tricks we know and see where they came from. In a drawn Lewis structure, you assign a formal charge to each atom in this way. Start with the number of valence electrons in the free atom. Subtract from that the total number of non-bonding electrons on that atom. Then also subtract half the number of bonding electrons on that atom. That last bit is the same as saying subtract 1 per bond on that atom. Let's look at an example. Let's assign a formal charge to each atom in nitrogen trifluoride. The fluorines are all bonded in the same way, so they'll all have the same formal charge. So look at any one of them. Start by writing down the number of valence electrons a fluorine atom has. That would be 7. Subtract from that how many non-bonding electrons are on the fluorine. 6. And subtract 1 for each bond. So 1. 7 minus 6 minus 1 is 0. For the nitrogen in this compound, nitrogen has 5 valence electrons. Subtract the number of non-bonding electrons on the nitrogen. That's 2. And subtract 1 for each bond. That's 3. 5 minus 2 minus 3 also equals 0. In a given Lewis structure, the sum of all the atom's formal charges must equal the overall charge of the whole species. If you assign formal charges and they don't add up to the charge on the whole object, you've assigned formal charges wrong. The purpose of assigning formal charges is to choose the best Lewis structure from several possibilities. Remember that you need to temporarily forget what you know about drawing Lewis structures. We're going to see how formal charge allows us to realize those rules. The best Lewis structure is the one that minimizes formal charges. If formal charges are all equal between several possible Lewis structures, choose the one that places a negative formal charge on the most electronegative atom. Look at the example, CH2O. How do we know whether to put a carbon or an oxygen in the middle? We know by assigning and assessing formal charge. Let's assign a formal charge for every element in each Lewis structure. For any of those hydrogens, it has 1 valence electron. The number of non-bonding electrons on that hydrogen is 0, minus half the number of bonding electrons, which is the same thing as minus 1 for each bond, so that's minus 1, to give the hydrogen a formal charge of 0. That's true for every hydrogen shown in these two structures because they're all identical in their bonding. For carbon, it has 4 valence electrons, minus 0 non-bonding electrons on that carbon, minus 4 bonds for a formal charge of 0. For this oxygen in the left-hand structure, it has 6 valence electrons, minus 4 non-bonding electrons, that's the 4 dots, minus 2 bonds for another formal charge of 0. That's going to be impossible to beat all zeros. But for the sake of practice, let's look at the other structure drawn. The hydrogens are both zeros, as we said before. The oxygen in the middle here has 6 valence electrons, minus 0 non-bonding electrons, minus 4 bonds, for a formal charge of positive 2. For the carbon, 4 valence electrons, minus 4 non-bonding electrons, minus 2 bonds equals a negative 2 formal charge. These formal charges in the right-hand structure do add up correctly. They still add up to 0 since this is a neutral compound. But this is definitely not as good as the previous structure. This example illustrates why you're told to put carbon in the middle of a Lewis structure. That typically minimizes the formal charges. Make sure you understand the difference between formal charge and resonance. Resonance structures keep atoms in the same place and show a different arrangement of electrons, the location of the double bond in SO2, for example. These structures are both equally valid, and actually an SO2 molecule is best described by drawing both with a double arrow between them. When you're using formal charge to choose the best Lewis structure for a compound, the drawings are not equally valid. The atoms have been moved around, and one arrangement of atoms is better than the rest. Here's several possible structures for COCl2. From what we saw in the previous example, we can assume that it's one of the two structures on top because they have carbon in the middle. You can always prove that to yourself by assigning all the formal charges in those bottom structures and comparing. Between these top two structures, should we make a double bond to chlorine or to oxygen? Let's use formal charges and find out. In the structure on the left, the chlorine on the far left, formal charge will be calculated by 7 valence electrons minus 6 non-bonding electrons minus 1 bond for a formal charge of 0. Looking at carbon, it has 4 valence electrons minus 0 non-bonding electrons minus 4 bonds for a formal charge of 0 as well. The chlorine on the right in this molecule has 7 valence electrons minus 4 non-bonding electrons minus 2 bonds, which gives it a formal charge of plus 1. Oxygen at the bottom has 6 valence electrons minus 6 non-bonding electrons minus 1 bond for a formal charge of negative 1. We have a 0, a plus 1, and a minus 1. That does add up to 0, and this is a neutral compound, so they add up correctly. Let's see what formal charges we get in the other Lewis structure. Both chlorines here are actually bonded in the same way as the chlorine on the left in the previous structure. They have 6 non-bonding electrons and 1 bond, so both of these chlorines would have a formal charge of 0. In the same way, carbon here is bonded just like carbon was in the previous Lewis structure, so it has a formal charge of 0. For oxygen in this Lewis structure, we would do 6 valence electrons minus 4 non-bonding electrons minus 2 bonds for a formal charge, again, of 0. All zeros in this Lewis structure. The structure that minimizes formal charges is the one on the right. That's the best Lewis structure for this compound. It's more favorable for the double bond to exist with the oxygen than with the chlorine. In our last example, let's consider the thiocyanate ion. There's quite a lot of ways to draw this ion. We could start with the elements in the order shown. Do we use 2 double bonds? Do we put a triple bond on the right? Or maybe a triple bond on the left? Or we could alternate the order of the elements. We could try carbon on the left with sulfur in the middle. What about nitrogen in the middle? There's more combinations even after these, but for the sake of time and sanity, let's stick with these 5 possibilities. Assign formal charges in all of these structures. In the first structure that we drew, sulfur has 6 valence electrons, minus 4 non-bonding electrons, minus 2, 1 for each bond, which gives us a formal charge of 0. The carbon has 4 valence electrons, minus 0 non-bonding, minus 4 bonds, which also equals 0. Nitrogen has 5 valence electrons, minus 4 non-bonding electrons, minus 2 bonds, equals a negative 1. Those formal charges add up to negative 1, as they should, because this is a negative 1 ion. Keep assigning formal charges. In the structure drawn below with a triple bond on the right, sulfur is 6 minus 1, which equals negative 1. Carbon again will be 4 minus 0 minus 4. This nitrogen is 5 minus 2 minus 3, which gives me a 0. So between these two structures, both of them have 2 zeros and a negative 1 formal charge. Let's keep going. In the bottom Lewis structure, 6 minus 2 minus 3 equals a positive 1 for this sulfur. This carbon will again have a formal charge of 0, just like the one above it. This nitrogen would be 5 minus 6 minus 1, which equals a negative 2. That's definitely worse than the previous two options, so we know that's not our Lewis structure. In the Lewis structure drawn in the middle, carbon would be 4 minus 4 minus 2, which is negative 2. Sulfur would be 6 minus 0 minus 4 for a positive 2. This Lewis structure is definitely going to lose. Nitrogen here, 5 minus 4 minus 2 for a negative 1. In our very last Lewis structure, carbon would be 4 minus 4 minus 2. Nitrogen would be 5 minus 0 minus 4. Sulfur would be 6 minus 4 minus 2. So we know for sure it's one of these first two that we looked at over on the left. Again, they both have 2 zeros and a negative 1 formal charge on the atoms. So how do we pick between them? We put the negative formal charge on the more electronegative atom. So our choices are to put the negative formal charge on sulfur or on nitrogen. Which of those two elements is more electronegative? That would be nitrogen. So the first Lewis structure that we drew, based on formal charges, is the best option for the thiocyanate ion. You learned in Chem 1 to draw as many double bonds as you could before making triple bonds. You see that that is true here. All the tricks, all the little techniques that you were told came from using formal charges to find those tricks.